Okay, so today we're going to go over the cross product, and let's make this very quick and brief. So let's say we have two vectors v and w, which are in R3. This cross product only works in R3. You have to know that. And now let's say we have a resulting vector, because we are doing a cross product, which means we're inputting parameters and we get something resulting from them, and that's going to be the cross product. Let's say the cross product is C. Now C is a vector also in R3, and we're going to denote the cross product as V cross W. Now the underline just means they're vectors. That's just my notation. Now, since they're in V3, they have, since they're in R3, they have three elements. So V1, V2, V3, cross with W is, I'm just gonna put it here and say W1, W2, W3. Now C is, there's like a special way to do C. I'll give you the formula though. So it's just gonna be V2 W3 minus W2, W2 V3, and then it's going to be minus V1 W3 minus W1 V3, and lastly we're gonna have the V1 W2 minus W1 V2. So that's essentially the formula. And how I like to memorize them, they're just a bunch of crosses in different orders. So I would just start by doing a small trace of it. And like whenever you go from the right to left horizontally, you add a subtraction sign. Then the next one, I'm going to go after W1, I'm going to go to V1. So in this case, I'm going to go W2 to V1 in diagonal kind of way, and then we can say that this induces a subtraction sign at the start. I don't know, just an analogy to make it a bit easier to memorize this formula for now. Then we're gonna go W1, V1 to W3, and then V3 to W1, and then we have another horizontal line. So we can, I guess, indicate that as another subtraction sign. And yeah, and then finally V1 W2 V2 W1. Essentially, I don't think there's an easier way to memorize the formula, but for now this will have to do. Okay, I wasted a lot of time on that. Now properties. The properties of these products are that they're skew symmetric, meaning V cross W is not equal to W cross V, but instead it is equal to negative W cross V. We can even put brackets if you want. Other properties as linearity in both arguments. So if we want to talk about the first argument, then we have two properties to describe linearity. One of them, let's say A is a real number. If we have A times V cross with W, this is the same thing as A brackets V cross W. so you can multiply a later. Another property is if we describe another vector, say y in R3, then if we have v plus y cross with w, this is actually the same as v cross w plus y cross w, and yeah, so this is distributivity. It just means that we can multiply these. I guess it makes more sense the other way around. Yeah. Now second argument basically means it also works when constant is in the second argument, or this addition is happening in the second argument. So in the first case, it would be that we have v cross a times w, and that's also going to be a v cross w. We're not going to prove it, but this is a fact. So, and then v cross w plus y is equal to v cross w plus v cross with y. Oops. And now some properties that we should probably mention is that the resulting vector c over here is going to be orthogonal to both v and w, meaning they're going to have a 90-degree angle between them. So as you might be able to recall the dot product, essentially if you have a dot product of 0, then two vectors are orthogonal to each other. So that means that c dot v and c dot w, you can even flip them around since the dot product is indeed symmetric. They're both equal to 0. Other properties include a formula. So it's pretty interesting. So using a parallelogram, we can describe the magnitude of the cross product and create an equation to do so. So let's just establish v as a vector over here. It can go anywhere. It's just making an analogy. And let's say w is this vector. Ignore the bad line drawing. We're going to draw a parallelogram. That might be a bit too short. Something like this. I think ignore the scale, but as you can see, it's kind of a parallelogram. Basically, the magnitude of the cross product, which is c, like this, c norm, is going to be equal to the area between w and v. Now we can have an angle here, and we know a formula for this angle. Namely speaking, using the dot product formula, which is v dot w is equal to magnitude of v times the magnitude of w, and then cosine theta. So you can always use this to find the angle between w and v. Now we can do this way. So recall to get this one line over here so that we can compute the area times by doing width times height of the parallelogram. we just need to use basic trigonometry, so SOHCAHTOA, and we come up to getting the magnitude of v times, that's not a dot product, it's just the times the sine of theta is equal to this line over here. This is going to multiply by the magnitude of v as well, so that we can get the area of this parallelogram. And this is the magnitude of this vector c, the cross product. So that's a formula that you might want to remember. Now, what else can we do with this? You might ask. Now, something interesting is we've said that it's orthogonal to both vectors. So there's actually a rule where you can use your right hand to figure out whether or not the vector c goes up or down, because c is going to be orthogonal to both v and w, so it's gonna be kind of like this. The only way for it to do so is gonna be in like another dimension. It's going to be like this. That's why we only work in 3 dimensions. So it can go up or it can go down. Now a simple way to do it is, let's label this u and v for now. So obviously u and v are in R3. Now u is above v, okay, in this case, and if I flip it, v is above u. You want to use your right hand. This is going to be your right hand. Okay, so you want to put your hand right over u. In this case, you want your right hand to be over u. So it can be just putting it on u, put like your hand here, right? And then you want to curl your fingers towards v. In this case, we can't curl them towards v. We need to actually turn our hand around and curl, and that means it's going downwards. If that makes sense. And this should tell you the direction of the cross product vector. And that is pretty much it. I guess we can also, to wrap up, note that v cross with itself is going to be 0. You can try that yourself. Also, if 2 vectors are parallel to each other, well, we know that their angle is non-existent. 0, sine of 0 is equal to 0, so it's going to be a 0 vector. And that should be all about the cross product. Thank you.